So welcome, this is CAI International Mathematics 0607, Paper 6, 2020, version 61. Let us start to solve the question. Combining triangle numbers, 30 marks. Your advice not to spend more than 50 minutes. This investigation looks at the results when adding, subtracting, and multiplying triangle numbers. Here is a table of first triangle numbers. 1, you add 2, you get 3, you add 3, you get 6, you add 4, see the pattern, you add 5. Find the next pattern number, so you have to add 6. So it's going to be 21. See the pattern in those numbers. Complete the table. T2 minus T1, we can see that T2 minus T1 is 3 minus 1, which is 2. T3 minus T2 is going to be 3. T4 minus T3 is going to be 4. You can see that pattern. It's going to be in that way. So 2, 3, 4, and so on. 5 is already been filled for us. So the next number should be 6, and so on. So what is the pattern you can see over here? If it is 3, this number is 3. If it is 4, T4, 4. T5 means 5. T6 means T6. So over here it has to be n minus 2. It has to be n minus 1 and n. So always there will be some pattern. We need to identify that pattern, and it is going to be very simple. Now complete the table by adding two consecutive triangle numbers. T2 plus T1 is 4. So we can see that T2 plus T1 is 4. Next, if at all I add, it becomes 9. If at all I add the next two terms, 16. Then it becomes 25. So 1, 4, 9, 16. Then it is 25. So you can see it is a perfect squares. It is 1 square. This is 2 square. This is 3 square. You need to identify the pattern as soon as you see the table. 5 square. So this has to be 6 square, which is 36. So what is the pattern again over here? If it is 2, 2 square. If it is 3, 3 square. 4 means 4 square. 5 means 5 square. 6 means 6 square. If it is n, it has to be n square. So that's going to be the pattern. Use the last row of the table in the question number 2 to complete Tn minus Tn minus 1. Table 2. Tn minus Tn minus 1 is n. Use the last row in the table in question number 3. So it is going to be nothing but what? N square, the last row. By adding these two equations, these are the two equations, so add them out. If I add all these two equations, what am I going to get? Or else I'll write over here, Tn minus Tn plus Tn minus 1 is equal to n. Tn plus Tn minus 1 is equal to n square. I'm going to add it out. Tn n minus 1 gets cancelled. 2 times of Tn is equal to n square plus n. So from that, Tn equals n square plus n upon 2, which is the required equation. By multiplying those equations, so we are multiplying those equations. So I think so it is in the form of a plus b times a minus b. A plus b times a minus b formula is nothing but what? A square minus b square. A square minus b square is equal to n square times n is n cube. So we got this new formula. Give the numerical example of this result. What does that mean? We can plug in n value anything of our choice. So let us substitute n equal to 2. So t2 square minus t2 minus 1 square should be equal to 2 cube. Whether it is correct or not, we'll see. T2. What was T2? T2 is going to be 3 and T1 is going to be 1. So 3 square minus 1 square should be equal to 2 cube because this is T1. So 9 minus 1, 2 cube is 8. So yes, that is correct. So the formula what we have derived is correct. Now the sum of two triangle numbers sometimes equal to another triangle number. Sum of two different triangle numbers is sometimes equal to another triangle number. When this happens, we have a triangle triple. Start with the number T3 equal to 6. So he has started with a number T3 equal to 6. Then from the table in question 2, T6 minus T5 equal to 6, because in the table 2 we have learned that Tn minus Tn minus 1 is equal to n. So we are assuming n is equal to 6 over here. So this should be equal to T6 minus 1, which is T5. So we got n is equal to 6, so it should be T6 minus T5. That's what has been given, n equal to 6, so T6 minus T5. But 6 is nothing but what? T3. So T6 minus T5 equal to T3. Move this T5 to the other side, so it becomes T3 plus T5 is equal to T6. So what is the triangle triple? 3, 5, 6. Now he has given for us to do an example. Start with a triangle number T5 equal to 15 and complete the method of example to find another triangle triple. So 15. T5 is equal to 15. We know fifth term is going to be 15. So now I want to take 15. So according to that formula, what was that? Tn minus Tn minus 1 is equal to n. If n is 15, so this has to be T15 minus T15 minus 1 is T14. So plug in T14 is equal to 15. But 15 is T5. So what is that? T15 minus T14 is equal to T5. So move this T14 to the other side. So it becomes T5 plus T14 is equal to T15. So what are the triangle triple? 55, 14, 15. 5, 14, 15. In the table, each row is a triangle triple. Use that one. So 5, 14, 15. We have done that one. Now we have taken 6. The triple, we have taken it as 6. 6 has been considered, 15 has been considered. We have not considered 10. So we are going to consider 10 next. It's going to be 10. So what is 10? We can see that T4 is 10. So go over here. T4 is 10. If I want 10, according to that formula from the table 2, Tn minus 1 is equal to n. So if n is 10, that becomes T10 minus 1 is 9. So T10 minus T9 is equal to 10. T10 minus T9 is equal to 10. 10 is nothing but what? T4. So what do I get from there? T4 plus T9 is equal to T10. So what is the triple? 4, 9, 10. Now, once you get this one, you can see the pattern. What is the pattern over here? 5 plus 4 is 9. 9 plus 5 is 14. So what is this difference? 4. What is this difference? 5. So next difference should be 6, which is 20. Next difference should be 7, which is 27. Or you can prove it out in this way, but it is very tedious and time consuming. So we have to check the pattern and do that. Every time there will be a pattern. Now what is the difference? 4. And what is the difference? 5. So the next difference has to be 6, which is 21. The next difference has to be 7, which is 28. Now when you add the last two rows in the table in question number 2, you get an expression for Tn minus 2. This is the difference between two triangle numbers that are 2 apart. Give the expression table 2. Last two rows of the table 2. This is table 2. Last two rows. So let me copy this part and paste it over here. I'm adding the last two rows. When I'm adding these last two rows, Tn minus 1 gets cancelled. Tn minus 2 is equal to n plus n minus 1. So which is nothing but what? 2n minus 1. So this is the difference between, so minus, right? This is the difference between two rows which are 2 apart, the triangle numbers which are 2 apart. The difference between those two triangle numbers is 2. Then Now he has already given that Tn minus Tn minus 2 is 15. So this value we have just got as 2n minus 1 is equal to 15. So 2n equal to 16. So n is equal to 8. So what is the value of n? 8. Next, what is he telling? T5 is equal to 15. Use your answer in part 1 to find a triangle triple. The smallest number should be 5 and the difference between the two numbers is 2. Difference between the two numbers should be 2. So I have to have T5 is 15. Now from here we can see that if I have 15, it can be written as Tn minus Tn minus 2. And n value is nothing but what? 8. So it becomes T8 minus T6 is equal to 15. But 15 is nothing but what? T5. So it can be written as T5 plus T6 is equal to T8. So again it forms a triple. So 5, 6, 8. 5, 6 and 8. Is the smallest number among them is 5? Yes. Is the difference between these two numbers is 2? Yes. So therefore 5, 6, 8. So everything is interrelated. He has given T5 is 15. I carried that 15, but now we have done that just now in the previous one. Tn minus Tn minus 2 is 15. So I have used that one over here. Tn minus Tn minus 2 is 15. So just now we got n is 8. I plugged in n is 8. T8 minus T6 is equal to 15 is T5. So from there I get the value of 5, 6, 8. Coming to the question number 7. By adding rows in the table in question 2, show that Tn minus Tn minus 3. So I think so we have to add 3 rows. So what am I going to do? Go to the table number 2 and copy down the 3 rows. So I get over here 3 rows and I try to add them up. Tn minus 1, Tn minus 1, Tn minus 2, Tn minus 2 gets cancelled. Tn minus 3 is equal to n minus 2 plus n minus 1 plus n, which is going to be 3n minus 3. Now T14 is equal to 105. Use the part A to find a triple number where the smallest number is 14 and there are two numbers is difference is 3. So difference is 3 means we are going to use this one. Tn minus 3 should be equal to 105. But this value is nothing but what we have just done now. 3n minus 3 is equal to 105. So 3n is equal to 108, n is equal to 36. So I got it out, n is equal to 36. So plug in n is equal to 36, T36 minus T36 minus 3 is 33 is equal to 105. But what is 105? Just now 105 is nothing but what? T14. So T14 plus T33 is equal to T36. So what is the triple, triangle triple? 14, 33, 36. Is the smallest number 14? Yes. Is the difference between those two numbers is 2? Yes. So that's 3. That's going to be the answer. Find all the triangle triples where the smallest number is 14. So just now, if we added last two rows, I added last two rows. So I got 2n minus 1. If you remember, the formula was 2n minus 1. When I add two rows, the formula was 2n minus 1. So 2n minus 1 is equal to 105. We take it as 105. So 2n equal to 106. N is equal to nothing but what? 53. Then in that case, Tn minus Tn minus 2, Tn, then what am I going to get it out? Tn, Tn minus 2 is equal to 2n minus 1. So this value was n is 53, right? 53 minus 2 is 51. T51, 2n minus 1 is just now we assume it as 105. 105 is nothing but what he has given. The 105 is T14. So I get it out. T14 plus T51 is equal to T53. So what is the triple? 14, 51, 53. Is 14 is the smallest among all this? Yes. Is the difference between them is nothing but what? 2. Difference doesn't matter over here. 14 should be the smallest one. Now, if at all I'm adding 3 rows. 3 rows, if at all I'm adding it out, I have already done it. We have just now done it out. It was 14, 33, and 36. Now, what am I going to do? If at all I'm going to add 4 rows, how do I find? If I add 2 rows, it was 2n minus 1. You can see the pattern. If at all I add 3 rows, it's going to be 3n minus 3. 3n minus 3. Then if at all I add 4 rows, I need to add 4 rows. So obviously it has to be 4n minus. So see the difference over here, it is 2. So over here the difference should be 3. It should be 4n minus 6. So the difference should be 4n minus 6. Now 4n minus 6 is equal to 105. So 4n is equal to 111. So n is equal to 27.75, which is not possible. Next, I go for 5 rows in that case. So 5 rows, or else what I do, I move this working over here so that it is not confusing. So I go for 5 rows now. So it has to be 5n minus what number? You can see the pattern. It should be 4. 5n minus 10. So do 5n minus 10 is equal to 105. 5n is equal to 115. So n is equal to 23. If n is 23, then it becomes Tn, which is T23 minus T. It is 5 rows, right? So what does that becomes? 23 minus 5, which is 18, is equal to 105. So T23 minus T18 is equal to T14. So T23 equal to T14, or else I write that T14 plus T18 is equal to T23. So what is the triple? 14, 18, 23. Is 14 is the smallest number among those all? Yes, 14, 18, 23. 5 rows. Now I try for 6 rows. We shall still try. Just check it out whether 6 rows works or not. 6 rows. So it has to be 6n. And what is this one? Add 5. 6n minus 15. So what should I do? 6n minus 15 should be equal to 105. 6n is equal to 120. N is equal to 20. If n is equal to 20, so T20 minus 6 rows, 20 minus 6 is 14, is equal to T14. So again I get it out. It is 14 itself only. It is repeating the same 14. But triangle triples, I should be having 3 different numbers. But here I am seeing that I am getting 2 same numbers. So therefore, I don't do for what is this? 6n minus 15 is equal to 105. I don't do for that, because it is going to be the same numbers. Triples means it has to be the different numbers. So till now we got 14, 51, 53, 14, 33, 36, 14, 18, 23. And have we got any other one? Now we try for the 7 rows now. 7 rows. It's going to be 7n minus, see the pattern, add 6 to that. It becomes 7n minus 21. So 7n minus 21 should be equal to 105. 7n is equal to 126. So n is equal to, I think so, 18. Okay, it works. So T18 minus 7 rows. 18 minus 7, 11 is equal to T14. It does works, but what happens is the smallest number is not 14. I want the smallest number to be 14. So this is not considered. 11, 14, 18 cannot be considered. So I got it out as these three. So 2 rows I have taken, 3 rows I have taken, last 4 rows I have taken, 5 rows, 6 rows, 7 rows. Once 7 rows is not working, you can keep on seeing that 8 rows, 9 rows, 10 rows will keep on becoming less than 14. I want the number to be lesser than 14. But hold on. So we haven't taken the 1 row. If we have taken the 1 row, which we have done it out in this one, each row over here. Over here we have done the 1 row. So we take 1 row. What is 1 row? Tn minus 1. We should start with 1 row. So, but anyway, we are doing it the last, doesn't matter, 1 row. So it is Tn minus 1 is equal to n, if n is 105. So Tn minus 1 is n, is 105. Now this is not, the difference is not 105, n. What am I going to do that for that? Now I want the smallest number should be 14. So Tn minus 1 is equal to 105. So T105 minus 105 minus 1 is 104 is equal to 105 is itself is 14. So T14 plus T104 is equal to T105. So what is the number? 14, 104, 105. 14, 104, 105. So these are the 4 possibilities. So I have taken 1 rows, added the last 1 row, added last 2 rows, added 3 rows, added 4 rows, 5 rows, 6 rows, 7 rows. At 7 rows it becomes smaller, so I don't take 7 rows at all. 6 rows it becomes the number repeated. So I do understand this is a quite complicated one. This idea is not so easy to get it, but if you don't understand it, pause it, play it again and again, and you may be understanding, or play it with a slow speed and check it out how I got the answers as 14, 104, 105, 14, 51, 53, 14, 33, 36, 14, 18, 23, and why no other answers. Next part, modeling, question number 9 to 12. Speed of planets. You are advised to spend no more than 50 minutes on this part. This task is much more simple than the last one. This task looks at the models for a distance of a planet from the Sun and the time it takes to travel around the Sun. The task uses these models to find the model for the speed of the planet. Astronomers use astronomical units, AU, to measure the distance in space. One astronomical unit is the distance from the Sun to the Earth. In the 18th century, the German astronomer Bode numbered the planets Venus to Neptune from 0 to 7. The table shows his numbers and the distance from the Sun to each planet. Bode estimated the distance from Sun to Venus as 0.7. After that, for each planet, he used the following rule to estimate the distance of the next planet in the table. Double the estimate distance and subtract 0.4. In order to want to get the next distance, multiply 0.7 with 2 and subtract 0.4. So 0.7 times 2 is 1.4. 1.4 minus 1, 0.4 is 1.0. So 1.0. Next one, to get the next one, multiply 1 times 2 minus 0.4. So which gives me 1.6. Now for the unknown one, 1.6 times 2 minus 0.4, which gives me 3.2, 2.8. 3.2 minus 0.4 is 2.8. Next one, 2.8 times 2, which is 5.6, minus 0.4 gives me 5.2. Then finally, 5.2 times 2 minus 0.4, 10.4 minus 0.4 is 10.0. So we have done that. Complete the table. Bode's rule gives a good model for the planets Venus and Uranus. Work out Bode's estimate for Neptune. Is it a good estimate? So for Neptune, it should be 19.6 times 2 minus 0.4, which is, it should be giving it as 39 and 40.2, 39.2 minus 4, which should be giving us 38.8. Is it a good estimate? Because he estimated 38.8, but actual distance is 30.1, so it is no. So 19.6 times 2 minus 0.4, which is 38.8. So it is not a good estimate. No. Find an estimate for Mercury using Bode's rule. So Mercury, we have to go in the reverse way. So let Mercury be x. So 2 times of x minus 0.4 gives me 0.7. So 2x equals to 1.1, x is equal to 0.55. So Mercury would have been 0.55. Bode's rule requires doubling each time. So a possible model for the distance is r equal to a times 2 to the power of n plus b, where n is Bode's number, that is 0 to 7, and a r b are the constants that transforms the graph r equal to 2 power n. Write the two types of transformation. So whenever you are multiplying by a, so it is called as stretch. And whenever you are adding b, it is called as translation. So 2 power n graph has been stretched and translated. Using the information for Earth and Jupiter on page 8, write down the two equations. So I get r equal to a times 2 power n plus b. N is the Bode's number for Earth and Jupiter. For Earth, Bode's number is 1. For Jupiter, Bode's number is 4. And the distance is 1 and 5.2. So when I take for Earth, this is for Earth. So distance is 1. Let me use different colors. For Earth, it's going to be 1 is equal to a times 2 to the power of 1 plus b. So I get first equation 2a plus b is equal to 1. So he's asking us to write two equations, 2a plus b is equal to 1. Now for Jupiter, it was 5.2 and n was nothing but what, 4. So a times 2 to the power of 4 plus b. So it becomes 16a plus b is equal to 5.2. Show how solving these equations will give this one. So 16a plus b equals to 5.2. 2a plus b equals to 1. Subtract 14a equal to 4.2. So a is equal to 0.3. Plug in a value over there. 2 times 0.3 plus b equal to 1. So b is equal to 0.4. So the equation becomes r equal to a times 2 power n plus b, which is 0.4. The table shows the time t years it takes a planet to go once round the sun. The table includes dwarf planet series which Bode's rule predicts. A possible model for the time is t is equal to k times r to the power of p, where k and p are constants. Use the information in the table for Earth to find the value of k. For Earth, it is 1 and 1. So time is 1, k we don't know, and r is also 1 to the power of p. 1 to the power of p is anything, is 1 itself only. So 1 equal to k. So what is the k value? 1. 1 to the power of p is 1, because 1 to the power of anything is 1. Use the result in part 1 and the information in the table Jupiter. For Jupiter, find p correct to one place of decimal. So Jupiter 5.2 and 11.86. R is 5.2, T is 11.86. So 11.86 is equal to K was 1, R is 5.2 to the power of P. So I want to find the value of P. So I apply logarithms on both sides. So log 11.86 is equal to log 5.2 to the power of P. So log 11.86 is equal to P log 5.2. So P is equal to log 11.86 divided by log 5.2. Do by calculator. It should be giving you the answer 1.5. Write on the model T in terms of R. Now we came to know P is 1.5. So T and K was 1. So 1 times R to the power of P. P is 1.5. This is going to be the model. Is this a good model for the time that it takes from Mercury to go around once? Mercury. Time is 0.24 and the radius distance is 0.39. So I try to find the time, which is 1 times 0.39 to the power of 1.5. So when I simplify that, it becomes 2 decimal places 0.4. So the actual time is also 0.24 only. So answer is yes, it is a good estimate, because by calculations also we are getting 0.24 and the table is also predicting it as 0.24. So therefore, yes, it is a good predict. Assume that planets travel in a circle with the sun at the center. Use the model R equal to 0.3 times 2 to the power of n plus 0.4 to show that the average speed. So speed is equal to nothing but what? Distance upon time. So distances go around the sun, right? 2 pi r. Circumference 2 pi r by the time. Time is nothing but what? R 1 times r to the power of 1.5 or r to the power of 1.5. So it becomes nothing but what? 2 pi r to the power of 0.5, because 1 minus 1.5 is nothing but what? 0.5 in the denominator. Sketch the graph for S with N, S and N. So which one? We are going to graph this part. 2 pi square root of 0.3 times 2 to the power of n plus 0.4. So we go for the graphing calculator. I have taken decimal, so you can use your physical calculator and draw the graph. So I'm trying to use by decimal, so it's going to be the same. So what am I going to do? I'm going to draw the graph for 2 pi divided by square root of 0.3 times 2 to the power of x. N is not there, I just take it as x plus the plus is also there in the square root, so 0.4, that care has to be taken, and the limits are 0 to 5. So x values are from 0 to 5. That's the most important thing. You can see that it's almost all a straight line, and y-intercept is at 7.51. So I go back 7.51 and a straight line, almost all a straight line. So this is going to the graph. The graph in part B is approximately a straight line. That's what he's saying. Find the linear model. So find the linear model. So it should be in the form of y is equal to mx plus c. So c is just now we got 7.5. That is of no issues. C is equal to 7.5 we got. Now we need to get it out, the gradient. For getting the gradient, what you have to do? You have to get 2 points. Let us get 2 points. 2, 4.967 and go there 3 3.755. So 2 points I have taken, 2 4.967 4.967 and 3, 3.755. So I find the gradient, which is y2 minus y1, 4.967 upon x2 minus x1. So it should be something around negative 1.2. So negative 1.2. So if I use the calculator correctly, I use that calculator. So it is 3.755 minus 4.967 divided by 3 minus 2. 3 minus 2 is 1. So I get that answer, negative 1.212. Negative 1.212. So that's a straight line. So write it out neatly. Y equal to negative 1.21 x plus 7.5. I think so the last part, he says Bode's number for Neptune is 7. So we don't write x. We remember we have to write it as n. That care has to be taken. Bode's number for Neptune is 7. Show that your model does not give a sensible answer for the speed of the Neptune. Speed s. So therefore we cannot use the same alphabet. See very carefully. This is a small error, so I'm writing it out in red color. So 1.212 n s. So s is equal to 1.212. So what is that answer? S is speed minus 1.212 n plus 7.5. For Neptune, n is 7 minus 1.212 times 7 plus 7.5. So let us check what is this answer is. So I take this calculator and move it around. So it is negative, clear it off, negative 1.212 times 7 plus 7.5. So what is that answer I'm getting it out? I'm getting the answer as negative 0.984. Negative 0.984. That is the speed. But what is the speed according to the table? Now, which is a negative answer. So our answer cannot be a negative because it should be a positive, right? So it is a negative answer. So therefore, we tend to say that it's not a correct estimate. We are getting a negative answer. It is not a sensible answer because speed cannot be negative, means going in the backward direction. So it should be always a positive one. So therefore, it is not a sensible answer. Therefore, for Neptune, it doesn't work. I think so that completes the paper. See you in the next paper. Bye.